Hello everyone, welcoming you to Sourav Sir's classes. And today we are looking at the GATE 2024 economics paper, question number 59. Let x and y be two dummy variables that take the value of either 0 or 1 and follow a bivariate frequency distribution as given. So if a logit regression is estimated with y as the dependent variable and x as the independent variable, then the estimated coefficient of x is how much? And these is the frequency distribution that we are given. So let us first write down what the logit regression looks like, right? So let us suppose that y takes only two values. It is a dependent variable. So y takes the value 1 with probability p, and it takes the value 0 with probability 1 minus p. Correct? And y depends upon x. That means the conditional expectation of y given x is nothing but p. Right? So in logit regression, what do? We model this expectation of y given x, which is the p in our case, as e to the power alpha plus beta x divided by 1 plus e to the power alpha plus beta x. Right? So this is the model that we use in the logistic regression. And if you go back to the question once more, it is saying that given that y is the dependent variable, x is the independent variable, then the estimated coefficient of x is how much? So that means we want to estimate beta from this expression. Okay, based on the data that is given to us. And note that having written down the logistic expression, we can always linearize this expression and write it as log of p by 1 minus p as alpha plus beta x. Right? Okay. So based on this data, we will be trying to estimate beta. Now, if we take the original expression, then the probability that y is equals to 1 given x is equals to 1, because x can also take two values, would be e to the power alpha plus beta divided by 1 plus e to the power alpha plus beta, right? As for the logistic. And the probability that y is equals to 1 given x is equals to 0 would be e to the power alpha by 1 plus e to the power alpha. Correct? Let's say I denote the first one as p1 and the next one as p0. Okay, so that means if I write it in terms of the linearized version, log of p1 by 1 minus p1 would be e to the power alpha plus beta, and log of p0 by 1 minus p0 would be alpha. So if I subtract these two, that means log of p1 by 1 minus p1 minus log of p0 by 1 minus p0, that should readily give me the estimate of beta that we are looking for, right? So now from the table that we have, the data that we have, we will try to understand what is p1 and what is p0. So we are focused on y equals to 1, so that means the second row. So the probability that y is equals to 1 given x is equals to 0, right? So the first column is fixed, so that is 6 by 12. And the probability that y is equals to 1 given x is equals to 1. So that means the second column is fixed, so that is 7 out of the total 18, right? So P naught over here is 6 by 12 and P1 over here is 7 by 18, right? So that means if the numerator for P naught is 6 by 12, the denominator is also 6 by 12, so that will become log of 1, so alpha becomes 0. And in the first case, if P1 is 7 by 18, the denominator is 11 by 18, and alpha is already 0, so that means beta hat, the estimate of beta would be log of 7 by 11, which is minus of 0.451. So since the question has asked us to round it off to two decimal places, it would be 0.45. That's your answer to question number 59. Thank you.